Okay, so we're just going to get started. As a reminder, this section is a no calculator portion. Number 1, which of the following is an equivalent form of the expression 15x plus 24ax? Right off the bat, when it says which of the following, they are straight up telling you, look at the answers first. I generally tell students to look at the answers first on the SAT because it can give you valuable clues as to how to approach a problem. But in this one, they're telling you which of the following is equivalent. So I have this one 39ax squared that looks different from all the rest. And all these three have parentheses. But first, let's look at 39ax squared. So what they did there is they said, I can add these together because 15 plus 24 is 39. I've got an a and I've got two x's, so that's ax squared. Is that how that works? No, it's not. When we are adding like terms, those x's on the outside, they don't change. They just don't. So if I have x plus x, I do not get x squared, I get 2x. So that one is out. Let's look at our next options. All three of these have parentheses with a number or a variable outside the parentheses. So what they've done is they have taken out a factor, not necessarily the greatest common factor, but they have taken out a factor from this expression. So when I look at this, I go, what could come out of here? There's two places I need to look. I need to look at the numbers, and then I also need to look at the variables. So I have 15 and 24 as my constants, my numbers. I have this one a that's by itself, and then I have this pair of x's. So for the numbers, I go, well, 3 goes into both 15 and 24. So one option is I could take out 3, and that would leave, when I divide 15 by 3, I get 5. When I divide 24 by 3, I get 8. Now, amongst the variables, if there were an a attached to both of them, I could pull out an a, but there isn't. There's only an a on this second one, so the a has to stay behind. Now, the x's, there is an x on both of them, so I can pull out an x. In fact, I'm going to scoot this 3 over a little bit, and I'm going to pull out that x. And so there's no x's left behind. I just have my plus 3x times 5 plus 8a. But there's a twist, and this is where you have to be very careful because, and I admit, when I was going through this very quickly, I initially made this mistake. I saw 5 plus 8a, boom, and I'm like, there's my answer, and I moved on. Ooh, no, because look what they did. They were tricky. They put an x outside the front there, not a 3x. Okay, well, this answer that I got doesn't match any of them, so what happened? Well, first off, again, they're being tricky because they have that 5 plus 8a after you pull out 3x, but that's an x, not a 3x. That one's not right. This one up here, can you pull out a 39 out of 15 and 24? No. That leaves D. D is our only option, so what did they do with D? They didn't pull out the 3. They did not pull out the greatest common factor. They only pulled out the x. So that 15 stayed in there and that 24 stayed in there. They only pulled out the x. Now, if you were given this problem and were asked to simplify it, then you would have to pull out the 3. But this is not a simplify question. It's just saying equivalent. What's the same? What's another version of this? And D is the only one of those that is equivalent to the original. But they were awfully tricky with putting that C answer in there. Number 2, the formula D equals RT is used to calculate the distance an object travels over a period of time T at a constant rate R. Based on this formula, what is the rate R in terms of D and T? They love to throw in words and phrases that don't matter. They just do. You have to be careful, try not to get bogged down in some of this verbiage, this very flowery words. So this information, like this formula is used to calculate distance, it doesn't matter. None of that matters. None of that. Here's what matters. D equals RT. Based on this formula, what is the rate R in terms of D and T? Anytime we're asked, what is this expression in terms of this, or what is the rate R in terms of that. They're wanting you to get whatever they're asking you for that. In this case, what is the rate R? They want R by itself and say in terms of D and T. They want the D's and the T's over on the other side. That's what that means always. Like here's another example. If I had X equals Y times Z and I said, what is Y in terms of X and Z? They want you to do your little algebra magic and get Y by itself and everything else over on the other side. That's all it means. Again, all that sort of stuff about D equals RT is used to do the distance. That's true, but it doesn't matter here. It matters in other problems. It doesn't matter here. So they want to say, what is R in terms of D and T? The in terms of means those need to be on the other side away from R. So what do we do to get R by itself? Since this is R times T, we want to do the opposite of that. We want to divide by T. Make that a little clearer. That's a T. There we go. We want to divide both sides by T. That cancels the T on that side. And there our R is by itself. And over on the left is D divided by T. So A is my answer. On to number 3. Which of the following ordered pairs x, y satisfies both equations y equals x squared plus 3x minus 4 and x equals y minus 4? This, there's often more than one way to do a problem. That's true in a lot of times in math. There's more often than not, there's multiple ways to go at a problem. Always on a SAT or PSAT, think in terms of what's the fastest. You have a very limited time. We want to do what's fastest. So one thing I could do is I could try to factor this and rearrange this so it's y equals something, and then go, okay, if I factor it and then plot out some ordered pairs of this graph, that would get me the answer. It's going to take a long time. First thing I look at here is I go, okay, if I plug all of these into this equation, it's going to take me time. What would be faster? Plugging them into this equation, because it has to satisfy both equations. So if it doesn't fit this one, it's out. So I'm going to take these y's and I'm going to plug them in over here and see if when I subtract 4, I get these x's. All right, I'm going to zoom in just to make this a little easier. So I'm just right on it. X equals y minus 4. Okay, first one, negative 4 minus 4. Is that 0? No. Negative 4 minus 4 is negative 8. So this one is out. Okay, B, again, we're doing y minus 4 to get the x. 6 minus 4, does that equal 2? Yes, it does. B is still in the running. C, 14 minus 4, does that equal 3? No. 14 minus 4 equals 10. So this one is also out. Finally, 9 and 5. 9 minus 4, does that equal 5? Yes, it does. It's still in. That did not take me much time to subtract 4 from those numbers. And that's something you can do pretty quickly in your head. You don't have to write it out. And now I'm down to 2 answers, and that's much easier to plug into this. So I'm going to start at the top, 2 and 6. So I'm plugging in 2 every time there's an x. I'm also doing it because that's easier to calculate than 5. 2 makes it easier. The math is easier. Again, speed. We want speed here. So I'm going to plug 2 in wherever there's an x and see what I get. So 2 squared is 4. 3 times 2 is 6. And then just the minus 4. So if I have 4 plus 6 minus 4 plus 4 minus 4, those are canceling out. I am going to be left with 6. And that's what we said. So this is going to equal 6. So that is my y. So my answer is B, 2 and 6. Just to show you what would happen if I plugged in 5. Let's do that. So just to double check it. This is a good thing to do if you end up with a little extra time at the end. Like if you rush through it and you do as fast as you can because you know you have that time pressure, you can go back. You can do these kind of things to check and see, double check and make sure your answer is right. So here I'm going to check D. 5 squared is 25. 3 times 5 is 15 minus 4. Ooh, this is not going to be 9. 25 plus 15 is 40. 40 minus 4 is 36. That does not equal 9. So that's my confirmation. The answer is B. Number 4, which of the following is a solution to the equation 2x squared plus 4x equals 3 plus 3x squared? I'm going to rewrite this. Anytime I have quadratics, the way to solve them, the first thing you want to do is you want everything on one side and you want it to be equal to 0. So I'm going to move everything over here because I have experience in math at this point, a lot of experience. So my immediate thought is, oh, if I subtract 2x squared, it's going to leave a positive x squared over on that side, so I don't have to deal with a negative, and that's going to make it easier for me to solve. Is that the only right way to do it? No, you can absolutely move everything over to that side as well and still get the right answer. But just again, my math experience tells me this is the easier way to do it. But regardless, what we want to do is get everything on one side and have it all be equal to 0. So let's do that. I'm going to get rid of the 2x squared first. So I subtract it from both sides. Now I have just that 4x over there. And then 3x squared minus 2x squared is just a positive x squared. Now I need to get rid of that 4x. So I'm going to subtract 4x from both sides. And now I've got my 0 on the left like I want. Yay! And I've got these 3 terms, but I'm going to reorder them just to make them in nice little descending quadratic order. That x squared, that minus 4x, and the plus 3. So now this is a situation I can solve. This is a quadratic and I can factor it. You can also use the quadratic formula to solve it at this point if you prefer it, because it's a more simplistic, if you can call quadratics simplistic, but it's one of the easier quadratics to factor. So that's how I personally am going to choose to do it. So I'm looking for 2 numbers that multiply to 3, but add to a negative 4. Now, since they multiply to a positive, but add to a negative, the only things that multiply to our positive are 2 positive numbers or 2 negative numbers. Here they're adding to a negative number, so I know it's 2 negative numbers. So what 2 negative numbers would multiply to give me a positive 3, but would add to a negative 4? Well, this one is a little easier because 3 is prime. The only 2 numbers that multiply to 3 would be positive 1 and positive 3, or negative 1 and negative 3. So here I know these are negative 1 and negative 3. And yes, that does work. Negative 1 plus negative 3 is negative 4. So I know I can factor this as x minus 1 times x minus 3 equals 0. Now to solve this, to find these solutions, I need to set each of these separately equal to 0. So x minus 1 equals 0 and x minus 3 equals 0. Solving for x on this side, x is 1, and over here, x is 3. So I have my options. It says which of the following is a solution, because there are 2 of them. So I'm looking for either 1 or 3, and there is 3 as C being my answer. Number 5, if xy is the solution to the system of equations above, what is the value of x? Systems of equations, we can solve these through graphing, through substitution, or through elimination. And graphing I would not recommend here because you are not allowed to use a calculator, so that leaves substitution or elimination. Either of them would work. Honestly, if you're using substitution, I'm not going to go through all that because personally I think elimination is a little easier in this case. But just as a little brief aside, if you wanted to do substitution, since there's a single x right here, I would move this negative 10y over. So then I would have x by itself, and then I could plug that into this top equation and get my substitution. But if you'd like to see more in-depth explanations about substitution, I'm going to have a whole bunch of videos separately on all the topics that are covered in this video down below, so you can get more in-depth information on them if you need extra practice. But we're going to do the elimination. And right off the bat, I look at these 2 right here and go, okay, if I multiply all of these by 3, this will become a positive 3x, and these will cancel out. Woohoo, that's what I want. So that's what I'm going to do. I'm going to multiply all of these by 3. And I'm just going to kind of do it right here. So to keep it more clean, we'll say my work area clean. When I multiply this first one by 3, I get 3x. When I multiply negative 10y by 3, I get negative 30y. When I multiply 16 by 3, I get 48. Right, so next step in elimination is we're going to add all of them together. Negative 3x and 3x, they cancel out. They're gone. Yay! Negative 4y and negative 30y together are negative 34y. And then 20 plus 48, 68. Now, negative 34 times y equals 68. So to undo that, I need to divide both sides by negative 34. And when I do that, I get that y equals negative 2. And you're like, negative 2. Oh, wait, negative 2 is not there. They didn't ask us for y. They asked us for x. Always be careful. Double check what they're asking because they like throwing in little tricky things there. So if y equals negative 2, I go back to either of these two equations and plug in y for negative 2. I'm going to go to the second one just because. So x minus 10 times my y. And I'm going to erase this so we can just keep it a little cleaner here. So x minus 10 times a negative 2 equals 16. So what is 10 times a negative 2? It is a negative 20. So x minus a negative 20 is x plus 20 equals 16. So I'm going to subtract 20 from both sides, and I get that x is equal to negative 4. So C, let's circle that properly. C is my answer. On to number 6. The equation y equals 36 plus 18x models the relationship between the height y in inches of a typical golden delicious apple and the number of years x after it was planted. If the equation is graphed in the xy plane, what is indicated by the y-intercept of the graph? Oh, me. If you're like me, these word problems just make you feel tired all over because it's kind of my eyes glaze over. I think a lot of people have that problem with word problems. Even if the math involved is fairly straightforward, the words can kind of make things fuzzy, we'll say. All right, well, let's look at our original equation. Y equals 36 plus 18x. This is very close to being the slope-intercept form of a line. We just need to flip those two around, so I'm going to do that. Y equals 18x plus 36. Now, in slope-intercept form, this number by itself is the y-intercept. Now, they asked, what is indicated by the y-intercept of the graph? So this funky question, if the equation is graphed in the xy plane, what is indicated by the y-intercept of the graph? That is a fancy way of first testing that you know that this is slope-intercept form and that this is the y-intercept. But the question actually means is, what does 36 mean in this equation? All that just means, what does 36 represent? This is why people don't like word problems. So let's look at this and figure out what the 36 means. Now they're telling us, we go back and reread it, it's modeling the relationship between the height in inches. Okay, so y is the height of these trees. We've got these trees that have apples. It looks like a face. That was not intentional. Okay, so we have a tree that has apples, and y is the height. And x is the number of years after it was planted. It's telling us how tall these trees grow. So we take 18, assuming inches, we multiply by the number of years, it's growing 18 inches a year, and then we add 36, and that tells us what the height is. So you go, well, what would 36 be? Before I look at the answers in this case, just let's think about this logically. What would happen if I put a 0 in for years? What would I get? If I put 0 in there, it'd be 18 times 0 plus 36. 18 times 0 would be 0 plus 36 would just be 36. So at 0 years, no growth has happened. I get 36 for my height y in inches. So when the tree is 0 years after being planted, it's 36 inches. Okay, with that fact in mind, let's look at their options. The age in years of a typical apple tree when it is planted. No, there's nothing that tells us this would be 36 years old. B, the height in inches of a typical apple tree when it is planted. Ooh, I think we have our answer because as we said, when it's been 0 years, no time has passed since it's been planted. Our formula says it is 36 inches tall. So no time since it's been planted means it just got planted. So the height in inches when it is planted, B, 36. And so that looks like our answer, but let's just read our other ones just to make sure they're not being tricky. The number of years it takes a typical apple tree to grow? No. The number of inches a typical apple tree grows each year? No, that would be the 18 actually. So yes, B, the height in inches of a typical apple tree when it is planted is our answer. This one honestly is less about math and more about logic, but they are just testing that you know this number that's out by itself is the y-intercept in a line. Number 7, Giovanni wants to buy shirts that cost $19.40 each and sweaters that cost $24.80 each. An 8% sales tax will be applied to the entire purchase. If Giovanni buys 2 shirts, which equation relates the number of sweaters purchased, P, and the total cost in dollars, Y? Why is sweaters represented by P? I don't know. Shouldn't that be S or W? But no, it is P. So, okay, well, it is sweaters or P. Let's say sometimes with these, again, word problems, there's a lot going on. I like to rewrite them. So let's say, what did Giovanni do? We saw that Giovanni bought 2 shirts and that shirts are $19.40 each. Okay, so that's an absolute. $19.40 and he bought 2 of them. So how much did that cost him? 1940 times 2 is $38.80. All right, so that is a flat amount he has paid. But then he also bought sweaters. And we don't know how many sweaters he bought, but we know each sweater cost $24.80. Now up here, we took that amount of cost of a shirt and we multiplied it by 2. Down here, we have the cost of the sweater and we're going to multiply it by how many sweaters he bought. We don't know how many sweaters he bought. They said it was an unknown number. Who knows how many sweaters Giovanni bought? It's a mystery. So it's multiplied by P, this unknown number. However many sweaters he bought, we multiply it by the price of a sweater, $24.80. But that's not what you pay. If you live in the United States, and if you're taking the PSAT, you probably do, you know that you have to add the sales tax after you've added up your whole purchase. In this case, we are told it is an 8% sales tax. How do I add 8% to all this? I need to multiply by something to increase that. So if I were to multiply by 8% or 0.08, those are equivalent, I would just find out what is 8% of this amount. I wouldn't find what my total is because that needs to be added. If you're wanting to find a total with an increase, like the total amount is after you increase by 1%, you have to have that percent, but you have to add 100%. That 100% represents the original. So it's saying, I want the original amount plus 8% of the original amount. So 100% plus 8% is 108%. So I need to know what is 108% of this amount. 108% is the same as 1.08. So I need to multiply this whole thing by 1.08 to get my final price. And if I look at my answers up here, what I just wrote is option A. Let me erase these over so you can really see what I wrote there. There we go, very clear. So we have option A of 1.08 times 3880 plus 2480p. That is my answer. That is the formula that will tell us how much Giovanni spent. Number 8, a line is graphed in the XY plane. If the line has a positive slope and a negative y-intercept, which of the following points cannot lie on the line? So this is, there's a couple of things that are being tested in this. They're testing your knowledge of slopes. They're testing your knowledge of in this quadrant where the positives and negatives are. So positive x, positive y, negative y. So every number over here is going to have a negative x and a positive y. Everyone here is going to have a positive for both. Positive x, negative y, negative x, negative y. So what do we know here? It says if the line has a positive slope and a negative y-intercept. So negative y-intercept, it is crossing somewhere down here, anywhere down here. We don't know, we're not told. It's just somewhere down here. So I'm just going to pick a point. It literally does not matter for this. Now, a positive slope, if you have a line, you start going straight up and down. If I tilt this to the left, these are negative slopes. Negative, 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 going all the way down until you hit horizontal. Anything in this range from vertical going to the left down to horizontal, those are negative, horizontal, negative slopes. If you're at a vertical line and if you're going to the right down to horizontal in this range, these are all positive slopes. So any of these are positive slopes. If I take this ruler and I put it through here, now again, remember, vertical is not a positive or negative. That is an undefined slope. Horizontal is not positive or negative. It is 0. So it has to be at an angle. Vertical doesn't count. Horizontal doesn't count. So it's going to be going up to the right to have a positive slope. If I take this ruler and I'm pivoting it through here, I get all the way till almost horizontal, and I go all the way up and see if I can get it to almost vertical and try to keep it on that point. Almost vertical. Do you see how I am never crossing into this quadrant? It's impossible. I'm just not. I'm never going to. And anywhere that this ruler starts, let's say if we put it all the way up, but it's still a y-intercept that's a negative, and I go all the way up, I'm gonna put this all the way up to I'm put up to 89 degrees. There we go, 89 degrees. You see, it's still going over here. It is not in this area. It's kind of hard to see with these thick lines that I've drawn, but see, look, it's going off to the right ever so slightly. It is never going to go over in this upper left quadrant. So that's what we're looking for. We're looking for a point that would be in this upper left quadrant. So again, we want a negative x and a positive y. And look over here, only A and B have negative x's, and only B has a negative x and a positive y. So B is my answer. Number 9, a parachute design uses 18 separate pieces of rope. Each piece of rope must be at least 270 centimeters and no more than 280 centimeters long. What inequality represents all possible values of the total length of rope in centimeters needed for the parachute? All right, so first we have 18 separate pieces of rope. So like 1, 2, 3, 4, 5, 18 of them. Each of these is at least 270, but could go all the way up to 280. So I have 18 pieces of rope. So the smallest possible length of this rope would be, if they were all the lowest number, 270. So that would be 18 times 270. So that's my lower limit. That's the least amount of rope I could possibly have. But all these ropes could also be the full 280. So the maximum, I could have 18 pieces of rope that were 280 centimeters. So this rope could be somewhere in between here, but it has to be greater than or equal to 270 times 18, and it has to be less than or equal to 280 times 18. Well, look at my answers. First, it says in between 270 and 280. Well, I know that's not right. That's the length of one piece of rope, not 18 pieces of rope. That one's out. And the reason I'm doing this elimination is because we don't have a calculator, and I don't know about you, but I don't really want to multiply 270 times 18 and 280 times 18 by hand. So let's look at these and see if we can find a quicker way than doing that math by hand, since we only have about a minute and 20 seconds, I think, for each problem on this test. So let's look at B. I have a range from 4,860 to 4,870. 10. They are 10 apart. That can't be right, is it? No. Look what's going on here. 270 and 280 they are 10 apart, but it's being multiplied by 18 on both sides. So these two numbers are going to be 10 times 18, or 180 centimeters apart. So B, is that an option? No, they are only 10 centimeters apart. That's out. I look at D. Look, they're also 10 centimeters apart. That's not right. That one's out. Now C better be 180 centimeters apart. It is. So C is my answer. If you really want to go and hand multiply 270 times 18 and 280 times 18 at the end, like when you finished, if you have spare time, go back and double check it. You will still get this same answer. Just as I always say, look at the answers. They will help you a lot of times. In this case, saving you from doing a lot of written out multiplication. On to number 10. A carpenter has $60 with which to buy supplies. That's not going to get you very far nowadays. The carpenter needs to buy both nails and screws. Okay, so he has to. He has to buy nails. He has to buy screws. All right. Nails cost $12.99 per box and screws cost $14.99 per box. If N represents the number of boxes of nails and S represents the number of boxes of screws, which of the following systems of inequalities models this situation? I'm going to look at my answers first. I love to do that with these problems. It helps you out a lot. And I notice, look at my first two here. They're very similar. What's the difference in the first two? The only difference in the first equation in these is one has a greater than or equal to, one has a less than or equal to. Okay. And if I keep going, all of them have this same $12.99N plus $14.99S, but it's the greater than or equal to. Okay, so that's my difference in that first equation. I have two that say greater than or equal to, and I have two that say less than or equal to. All right, what's the second part of this? These two say N plus S is less than or equal to 1, and these two say N is greater than or equal to 1, S is greater than or equal to 1. Well, I'm going to start with that, because what does it say here? N is the number of boxes of nails, and S is the number of boxes of screws, and he has to buy boxes of both. So he has to buy at least one box of nails and at least one box of screws. So would 1 plus 1 be less than or equal to 1? No. It would be at least 2. So these two that say N plus S is less than or equal to 1, they are out. I only have to look at C and D. And the only difference between these is greater than or equal to 60 or less than or equal to 60. So this part here is saying how much money he's spending. He's spending $12.99 for every box of nails and $14.99 for every box of screws. And when he adds that up, is it greater than 60 or equal to, greater than or equal to 60? Or is it less than or equal to 60? Well, what is 60? It says up here he has $60 with which to buy supplies. And we're going to assume he's not putting this on a credit card, that he has this cash. So if he walks into the store and he goes up to the cashier with boxes that are greater than 60, is he leaving that store with those boxes? Of course not. He only has $60. They are not going to let him take those boxes out. So it has to be less than or equal to 60 because he's purchasing them and he only has $60. So D is my answer. On to 11. In the figure above, which of the following ratios has the same value of A times B over B times C? This one can be a little tricky to visualize. So I'm going to do my best to draw everything out to kind of show you what's going on here. The instant you see these two have the same angle, they're both 28 degrees, this should be a hint, a big hint that we're dealing with similar triangles. A lot of times in geometry, we have triangles that have at least one angle that's the same. They're hinting like these could be similar because similar only requires, to prove two triangles are similar, it only requires that there are two angles that are the same. It's called angle-angle similarity theorem. So if two of these angles, of two angles of triangles are the same, the triangles are similar, their sides are, the lengths of their sides, I should say, are proportional. So as soon as I see this 28 degrees here and 28 degrees there, I'm like, okay, I've got several triangles overlapping. I have this triangle, ABD. I have this triangle, BDC, but I also have this triangle, ABC. 3 triangles. Now, triangle ABC and triangle BDC share this angle. Angle C is in both of those triangles. All right, so I'm going to try to draw these triangles separately to make it a little bit easier to visualize. First, I have the big triangle out here, which this is my 28 degrees, and this is A, B, C. I just got rid of that little line that's in the middle. And now I'm going to draw this triangle. All right, and now I'm going to draw a triangle BDC, and something I have just figured out with Microsoft that's really weird is it won't let you rotate things easily. So we're going to make this like a weird sort of uniline picture. There we go. It's all one picture. So now hopefully Microsoft will let me, the whiteboard will let me rotate it. There we go. So there's our BDC, and we're going to, you've got to be kidding me. It still won't let me rotate it. There, no, wait, there it goes. Okay. All right, so I'm going to rotate this thing. And then now it is the mirror image of this up here. So hopefully it's a little easier to see that these are the same triangles. And we have that triangle C, which remember that was shared by both of them. So if you can imagine this being flipped horizontally, the whiteboard really doesn't want to let me do that. Then you can see these triangles are similar. So we want to set up a statement about these two triangles that shows how they relate to each other. And it's going to make this problem a lot easier. I'm going to zoom out a little bit. So up here on top, I have triangle ABC. Now look, I'm starting at that 28 degree angle. I'm going to the angle I don't know, and I'm ending at angle C. So I'm going to do that same thing over here on this smaller triangle. All right, so I'm starting with the 28 degrees, which is angle B. I'm going to the angle I don't know, which is angle D. I know it's upside down, but yeah. And then I'm ending at angle C. So there's my similarity statement. Triangle ABC is similar to triangle BDC. It's very important that the corresponding angles are in the same position. A is the same as B. B is the same as D. C is the same as C. This is super important. You have to do it this way. So same value as AB to BC. So they're saying the ratio of this side to that side. We're going from 28 degrees to the side we don't know, to angle C. So I want to do the same thing over on this side. I'm going to start at 28 degrees to the side I don't know, and then the side I don't know to C, BD to DC, and that is A. Another way you can do this is with the similarity statement itself, if you've written it correctly. So if we've got it correct, our thing we're saying which of it is equivalent to AB over BC, these first two letters over the second two letters. So we follow that same pattern, BD over DC, right there. Either way, both of those are good ways to do it. Just be really careful when you're flipping that triangle over mentally or drawing it out to make sure you're doing the corresponding angles correctly. So it is the ratio of BD to DC. A is my answer. On to 12. If the equation above where A is constant is true for all positive values of X and Y, what is the value of A? So there's no zeros in here. Don't have to worry about that. They're testing your knowledge of exponent rules. So let's break this down. First little group here, I have x squared times, we're off to a great start there, aren't we? There we go, y cubed, all to the power of 1/2. I'm going to start with that first, just this little chunk first. I'm going to ignore the rest for now. These are power to a power situation. This is x squared to the power of 1/2, y cubed to the power of 1/2, so power to a power. When it is a power to a power, you multiply. So 2 times 1/2 is just 1. So I have x to the power of 1. You normally wouldn't have to write it, but I'm going to do it just to keep things consistent. Next one, I have y cubed to the power of 1/2, 3 times 1/2. Y to the power of 3 halves. All right, here's my next one from there. Next one on the list is x squared. And this is it's still in its parentheses here. I'm going to keep it there. All right, so x squared times y cubed to the power of 1/3. Same thing, power to a power. X squared to the power of 1/3, 2 times 1/3 is x to the power of 2/3. Power to a power, y cubed to the power of 1/3, 3 times 1/3 is 1. Y to the power of 1. All right, so now they're saying, once I have that, this equals x to some power times y to some power. So I know I need to multiply these together. Well, now it's not power to a power, it's just straight multiplication. It's x to the first times y to the 3 halves times x to the 2/3 times y to the power of 1. So when we have that, when you're just multiplying, but you have the same base, in this case, you add the exponents. So I'm going to reorder these because they are all just being multiplied together. So I'm going to reorder as x to the power of 1 times x to the power of 2/3 times y to the power of 3 halves times y to the power of 1. Now these have the same base, so I can add their exponents. What is 1 plus 2/3? Now, when we're dealing with fractional exponents, we do not want mixed numbers. We don't want like 1 and 2/3. We need it to be a improper fraction with that big numerator. So 1 is the same as 3/3. Those are the same. 1 is 3/3. So 3/3 plus 2/3, I'm going to write all this over here. 3/3 plus 2/3 is 5/3. There's my first one done. Then I have my y's. Y to the power of 3 halves times y to the power of 1. 1 is the same as 2 halves. So 3 halves plus 2 halves is 5 halves. So I got my answer as x to the power of 5/3 times x to the power of 5 halves. And let's look at that problem very carefully. It says, a is a constant. X to the power of some thirds and y to the power of some halves. What is a? Well, looky there. That's further proof that we did it right because we did get a 5 for both of them. A is 5, so C is my answer. Moving on, number 13. This is the last of the multiple choice. If the question y equals x minus 6 times x plus 12 is graphed in the xy plane, what is the x coordinate of the parabola's vertex? The easiest way to do this is with the axis of symmetry. Every parabola has an axis of symmetry. It is a straight line that it goes right through the vertex, and it splits the parabola perfectly into two symmetrical halves, hence axis of symmetry. If you have a parabola that's written in this form, ax squared plus bx plus c, where a, b, and c are those constants or numbers, then the formula for the axis of symmetry is x equals negative b over 2a. So you take the opposite of that middle number and you divide it by 2 times this first number, and that gives you this axis of symmetry, which is x equals a number. You might be saying, but they didn't ask for the axis of symmetry. They asked for the x coordinate of the vertex. Yes, but this axis of symmetry goes through the vertex, and it's an x line, x equals. So wherever this vertex is, its x coordinate is going to be the same as this line. So the quickest way to do this, honestly, is to take this, this factored quadratic, it's been factored, and use FOIL, or binomial multiplication, depends on your book what they call it, to get it into this version, this form. So let's do that. We have x minus 6 times x plus 12. And I'm going to use FOIL. So I multiply my first terms, x squared, my outside terms, 12x, my inside terms, got my x, there we go, and my last, negative 6 times 12 there, negative 72. And when I combine like terms, I get x squared plus 6x minus 72. Now I'm going to use my axis of symmetry, x equals negative b over 2a. My b in this case is 6, so negative 6, the opposite of that b, negative 6 on top. And then my a is an invisible 1, so over 2 times 1. So negative 6 over 2 times 1. Negative 6 divided by 2 is 3. There is negative, zoom out a little bit. You can see some of the next problem. Oh, well. So negative 6 divided by 2 is negative 3. So negative 3 is my axis of symmetry and means that wherever that vertex is, negative 3 is also the x coordinate for that vertex. All right, on to 14, the first of the no multiple choice questions. In the equation above, a is a constant. For what value of a does the equation have an infinite number of solutions? You get an infinite number of solutions to an equation when both sides of the equation are identical. For example, x squared plus 7x plus 2 is equal to x squared plus 7x plus 2. That would have infinite solutions because it's every number that goes in there is going to make that true. So let's see if we can find a way to make this the same on both sides. On the left, I have 21x plus 14. On the right, I have 7 times 3x plus a. Well, I want to get rid of these parentheses. So I am going to distribute. So first I have 7 times 3x is 21x, and then 7 times a is 7a. So still have the 21x plus 14 on the left, and I have 21x plus 7a on the right. These are very close to being identical. The 21x's are the same, so now I need those second terms. I need 14 and 7a to be the same. So what does a need to be to make this true? If 14 equals 7a, I want to divide both sides by 7 to solve for a, and I get that a equals 2. That's my answer. A needs to be 2 for this to have an infinite number of solutions. Number 15. Julianne practiced her dance routine for twice as many minutes on Monday as she did on Tuesday. She practiced her routine those 2 days for a total of 2 hours and 15 minutes. How many minutes did Julianne practice her dance routine on Monday? Okay, so on Monday and on Tuesday, I'm going to say her number of minutes that are sort of the unknown or x. That's a variable I'm going to be using is x. Okay, twice as many minutes on Monday as she did on Tuesday. So if she practiced for x minutes on Tuesday, she practiced twice as long on Monday, so 2x, for a total of 2 hours and 15 minutes. So together they equaled 2 hours and 15 minutes. To make this easier to solve, I want to convert this into just straight minutes. So there are 60 minutes in an hour, so I want to multiply that by 2 and then add that 15. 60 times 2 is 120, plus 15 gives me 135 minutes. So I'm going to replace this with 135. Okay, so on the left side I have 2x plus x, that's 3x. Equals 135. I need to divide both sides by 3. So 135 divided by 3 is 45. And the question is not what does x equal? The question is for how many minutes did she practice her dance routine on Monday? We said on Monday it was 2 times x. Since x is 45, 2 times 45 is 90. She practiced her routine for 90 minutes on Monday. Number 16. In the expression below, a is an integer. So we would think of like a whole number or a negative number, but always no fractions. It's going to be like -5, -3, +7, 1, 25 million. These are all integers. 12x squared plus ax minus 20. If 3x plus 4 is a factor of the expression above, what is the value of a? Okay, so we have this quadratic, and they are partially factoring it for us, which is nice, honestly. So I have 12x squared plus ax minus 20. And they're saying 3x plus 4 is a factor. Well, I want to figure out what the other factor is. Well, let's do this. So I know this first term times this first term, when I multiply those together, those are going to give me that 12x squared. This is going to be something with x. So 3 times what equals 12? That's going to be 4. And now I have this term, negative 20. The last term is always these two terms multiplied together. So 4 times what equals negative 20? Negative 5. Okay, so there it is. There's my factor, 3x plus 4 times 4x minus 5. So to find out what a is, I need to multiply all this fully using FOIL. All right, so first 3x times 4x, I better get 12x squared, and I do, that's good. Then our outside terms, 3x times negative 5 is negative 15x. Then our inside terms, 4 times 4 is a positive 16. And then finally, last, 4 times negative 5 is negative 20. Now I'm going to combine like terms to simplify. 12x squared stays the same. Negative 15x plus 16x is just 1x, negative 15 plus 16 being 1. And then negative 20. So they're asking, what's our question again? What is the value of a, where a is this term next to x? It's 1. 1 is the invisible constant that is next to x. So a equals 1. Number 17. Oh, this problem. This one is evil. Honestly, I looked at this and I initially thought they were asking to do a whole mess of math, and this is a 25-minute, 17-question test, so you're looking at a minute to a minute and a half for every problem. You can't be doing a problem that takes forever in a day. And this looked at first glance to me like one that would take forever in a day. But oh no, they're being tricky. It's actually super easy. Oh man, it's evil. Okay, so ax, without any further ado, ax plus by times cx minus dy. In the expression above, a, b, c, and d are non-zero constants, and a times d equals b times c. If a times c equals 18 and b times d equals 50, what is the value of the coefficient of the xy term when the expression is multiplied out and the like terms are collected? My immediate thought was trying to figure out, okay, is there a way, if AC is 18 and BD is 50, and I know AD is BC, is there a way I can figure out? And I was writing factors of 18 and factors of 50 and trying to, oh my goodness. And I'm like, this can't be right. This cannot be right. And it was not. Here is the way to do this. And this is one of those problems that kind of takes a little moment of epiphany. And if you have it, you're going to get this very quickly and very easily. And if you don't, you're probably going to be staring at it and tearing your hair out. Okay, so I'm going to multiply these, but to really make it clear, I'm going to write my variables in green. Green meaning go, they can change. So my x's and my y's, I'm going to write in green. And then my a, b, c, and d, because they are constants, they're not going to change, I'm going to write them in red. Hopefully keep this a little clearer here. All right, so first, ax times cx. So we have a times c, x times x is x squared. Then I have my outside, ax times negative dy. Okay, so I have negative a times d, and my little variables, x times y. Then I have my inside, by times cx. So that is bc times xy. And then last but not least, I multiply my last ones together, which is by times negative dy. So that is a negative bd, and then the y's multiply together to get y squared. All right, so I have ac x squared minus ad xy plus bc xy minus bdy squared. And things are about to get really super simple because look at what they gave us originally. They said AD equals BC. Honestly, that AC 18 and BD 50, I can put those in there, but they don't really matter. All that matters is this right here, AD equals BC, because look at what's going on in the middle, because they're asking, again, they're asking the value of the coefficient of the XY term. This in the middle, this is what they want to know. They don't care about those. They just want to know what this one is. And we've been told A times D equals B times C. Put any numbers you want in here. Let's say A times D is 5. That means B times C is 5. What happens if we put 5 in for AD and 5 in for BC? It cancels out. -5, +5, they cancel out. Any number in the universe that you put in here, any non-zero constant you put in here, this is going to work. So let's say AD is, 572. So that means BC is 572. Okay, well, we're placing AD here. So that's 572. We're placing BC here. So that's 572. -572 plus 572 is 0. It's always going to be 0. That's it. It's gone in the middle. 0. That's our answer. So it's like, I'm just back at, there we go. AD and BC, they're going to cancel out because AD equals BC. Always. 0. 0 is my coefficient for that middle term. If you would like to plug in the AC and the BD, you can. It doesn't really mean anything. If AC is 18, then that means this right here is 18. And if BD is 50, they tell us that, so that means that is 50. Yeah, I mean, it makes it look a little prettier, but it doesn't change anything because, again, all they want is what is the value of the coefficient of the XY term in the middle. And no matter what you do, these two are going to cancel out because AD is BC, so the coefficient on that term is 0. I have a love-hate relationship with this problem. I mean, it's clever. I think, from a math geek's perspective, it's kind of cool, but I also think it's kind of mean. I just do. It's just kind of a mean one to end on to make you go, what? What is going on? But that's it. You made it to the end. Congratulations. If this was helpful or useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.